Hello, everyone. I'm Gary Berman from DevOps.com and the host of the Cyber Hero Adventures show. It's a pleasure to welcome you to another great DevOps.com webinar. Thanks for joining us. Today we have Eric Mizell, VP of Solution Engineering at OverOps, Gavin McLaughlin, Site Reliability Engineer at Expedia, and Ravi Vankamamidi, Director of Technology at Expedia Inc. We're going to learn about how Expedia improved developer productivity and reduced MTTR by over 90%. But before we get to today's presentation, let's go over a few housekeeping items. We use the GoToWebinar system, so for many of you, you'll see the control panel. Please take a moment to click on the questions icon and the little downward arrow. Our guests will be answering questions throughout the presentation. This webinar is designed to be highly interactive with our three great speakers. We do welcome your questions and comments and suggestions, and we'll get to as many as possible. If we can't get to your question, we'll email the replies to you shortly. So you know, this webinar is being recorded, and the slides will be available to you on demand at devops.com in a couple of hours. Additionally, we have a giveaway for 4 $25 Amazon gift cards at the end of today's webinar, so stay tuned to see if you're one of today's lucky winners. And now, a special thank you to our sponsors for today's webinar. Let's get started. Eric, take it away.
Awesome. Thank you so much. Thanks for all of you who attending. So quick round of introductions. Again, my name is Eric Mizell. I run solution engineering here at OverOps. By quick background, I'm a software engineer, written software for years, and then moved into a field engineering role at companies like Terracotta, Hortonworks, and at OverOps. So working with lots of customers on lots of complex distributed application problems. Ravi, would you like to introduce yourself, sir?
Yes, I'm Ravi Vankamamidi, Director of Technology at Expedia. I'm responsible for building a large-scale, scalable, intelligent, context-aware conversational platform for the travel domain. I've been working for over 20 years building distributed systems which are mission critical and working with really cool and high performance individuals.
Perfect. Thanks, Ravi. And Gavin, how about a quick intro?
I'm Gavin McLaughlin, the Site Reliability Engineering in Expedia. Site reliability engineering means a lot to a lot of different places. So in a nutshell, if the developers are the cars or the trucks that are delivering the end goods to the customer, I'm in charge of trying to design the freeway system, the superhighway, with all of the road signs and the pavement and the markers to keep everybody safe and moving at a fast speed.
I like it. Nice analogy. All right, so what are we going to talk about today? So we'll cover a few things. First and foremost, we'll talk a little bit about what the landscape looks like at Expedia, and especially in the world of COVID, right? I think things have changed dramatically. I'm sure most of you are following the digital experience, and many of you probably are living it, right? Things have changed dramatically to touchless. We rely more on our phones and our devices and our apps and applications more than ever, and if there's issues, it can be devastating, especially for travel. Then we'll look at some code quality and reliability challenges that Expedia has had in their pipeline and how they troubleshoot. And then finally, we'll talk a little bit about how continuous reliability has helped Expedia to reduce MTTR and MTTR, to increase feature releases, get more productivity and more release features from their engineering teams. And now I will give you a quick demo of what we talk about today. So you can take a look at it live with the product OverOps, and then we'll do Q&A. Now, keep in mind, we will take some questions along the way if they sort of fit the topic we're on, but at the end, we have a final Q&A session. So please put those questions in the question tab, and we'll be happy to answer those. All right, so Ravi, give us the landscape of what it looks like at Expedia.
So for those of you who don't know, Expedia Group is world's leading travel platform, which with such trusted brand names as Expedia.com, Hotwire.com, and Verbo.com, among others. You know, the best way to define what Expedia does is we literally serve the travelers. I mean, that's at the core of what we do as part of our business. Now, while so Expedia is a really large organization, I will specifically be focused on talking about the conversation platform of which Gavin and I are a part of. So, in order for us to, especially in these days of pandemic and post-pandemic, where the amount of human interaction is becoming less, we really want to enable more and more channels to talk to the user, right? So we effectively have to make sure that we're enabling travelers with all their self-service options rather than waiting on a call for a really long time to talk to an agent. If we can expose things that the agents don't have to answer, then the quality of questions that our agents get will be much higher, which will be much higher value. And eventually, when we cannot answer questions, when the conversation platform cannot answer the questions using bots, then we would transfer over that conversation pretty seamlessly to a human agent who have a lot more tools, and he or she will be able to answer the questions for really complex travel problems. Next slide, please. So the context for today is, when we're talking about the conversation platform, we are talking about reaching the user in a multi-participant, multi-channel environment, where it could be on a Facebook Messenger or a WhatsApp or a chat channel, where using our own native apps, or even on a voice channel, using emails, using SMS. Imagine that the backend for all these things is exactly same, right? Irrespective of which channel you're coming from, you will have an adapter that converts the conversation platform language into the external language, and vice versa, as the messages are traveling back and forth. The foundation, because we have to handle multiple customers with potentially speaking different languages, potentially using different incoming channels, we chose an event-driven architecture where it enables us to do fairly loose coupling between different systems, and we can introduce new technologies pretty seamlessly. Like today we may not have translation service, tomorrow we might. Today we might have a routing based on the loyalty of a customer, and so think of conversation platform as an event-driven architecture that is distributed and scalable. Effectively, it's a fairly complex piece of set of technologies that come together to make the entire platform. So right from like I said, the clients at one end, like Facebook Messenger or something on one end, and all the way to the global distribution system, either for hotels or for airline on the other end, and everything in between. So the fundamental thing that when you think of when we think of the problems, one of the things that stands out for us is the fact that our system is very complex and real time, so we cannot afford too much of downtime. We can't take a lot of time to troubleshoot and try and figure out what's happening there. Next slide, please.
All right, so I'm going to talk real quickly about some things that are very important for us for site reliability and keeping this site up and going. Number one, as you start talking about DevOps, pretty much every subject, every webinar, everything has inspiration drawn from the Toyota manufacturing when they revolutionized the industry. And I think we all can recognize what happens when an issue gets to production. but Toyota really called out what happens if your issue happens after the bottleneck, if your defect happens after your key constraints have happened, how expensive that is for the speed of delivery. And so really what we're aspiring to do is get as much quality in the source, catch the defect as close to the source as possible, so that ultimately we can drive faster with a much more higher quality product. Data-driven decision making, I think we can all empathize how many decisions are made at every enterprise that are gut feel, finger in the air, feel the wind going. And so we're always aspiring to try to quantify those decisions, get better at measuring things, and make the right business-driven decisions off of that. Continuous improvement, we're a big fan of Deming and the Plan, Do, Check, Act, and constantly improving. Small incremental changes mount up to a huge change after a period of time. Shared responsibility, we can't do it all. You can't focus on everything. You'll move way too slow with all the context switching. You have to be able to focus. So you have to be very targeted. And so it's very important to have a defined accountability structure, as well as who's working on what, so that you can all work on what's important together. And then protect the platform, whether you're talking about chaos engineering and planning for failure, or what happens when you succeed and you get a vast burst of traffic to your site because your marketing campaign was successful. How do you protect your platform as a whole? So those are really our core values there. Next slide. And so I want to walk you through a scenario that hopefully that you can relate to. Imagine that you booked a trip to Europe with your family and you wanted to save costs, so you booked a hotel. Nothing could possibly happen, so you booked it non-refundable, and then an unforeseen event happens that no one could imagine. I don't know if you can imagine yourself in a global pandemic where perhaps you can no longer get to your Europe destination, right? And with the pandemic, everybody's facing the same problem, and everybody wants to know what am I going to do with this? And so they're calling their support lines. And so when you pick up the phone, as Ravi mentioned before, you have a 45-minute wait or longer, just like the phones are swamped. So you find this self-help feature, this chat widget, and you say, you're trying to find these answers to what happens to my hotel. Am I going to get my money back? That was a lot of money. That wasn't just, my piggy bank broken out. And you encounter an error, right? Like, how frustrated are you going to be? How stressed are you going to be? And so that's really what we're trying to alleviate from these type of scenarios. Next slide.
Perfect. Thanks, guys, for the background. Does hit home, right? Can't imagine, especially if you were stuck in a country and you had to change a flight, or your hotel was closed. I mean, there's a million flavors here that you guys are dealing with. So great background. Thanks for that. As we get into code quality and reliability, we'd love just to give, what were some of the challenges you had prior to OverOps? Rob, if you could just give us a quick background.
Right. So we have, like I mentioned before, we have lots of microservices in the system, and consequently, it's a highly distributed system, and not to mention that it's an asynchronous system. What that means is it is, once something starts not working, it'll take some time for all of our monitors to catch it, because a lot of times it might not even be something very apparent. So the flow was effectively, we had the log files, so we have an alert, and then once that alert fires off in Datadog, we'll get a pager duty, and then we would, then go to Splunk or something like that and try and figure out, what happened. All of this takes time, logging into systems and looking at stuff and trying to correlate. OverOps literally cut down all of that time down to, we can set alerts in OverOps itself, and we can look at the site reliability in OverOps. So, and the moment we see some anomaly, we will be able to quickly know the entire context around that problem. So, previously, it was primarily the developer that developed that particular module or that particular code. But now anybody, because it has enough context around that bug, can quickly go in and put a fix in, at least a workaround, so that the amount of challenges we have had with prior to OverOps, they have been cut down quite a bit with OverOps.
Perfect. Perfect. All right, let's jump into your tech stack a bit and kind of give us the broad landscape here.
Yeah, so at a very high level, like microservices, we have several. We have a polyglot environment. We have Java, Kotlin, Python, Node.js, whatever is the favorite language of the developer, and also what suits that particular need the most. We have Kafka at the heart of our system, which ours is an event-driven architecture. So all of these microservices are loosely coupled using events. We use GraphQL at places. We use RESTful services at places. Again, looking at the entire ecosystem, it's not one or two services. It's effectively tens of services, if not hundreds, tens of services that effectively make the platform, the conversation platform. In addition, we also have partners that build their own business logic, plug in their services into the conversation platform. But all of this ecosystem exists within the AWS cloud infrastructure. We use NoSQL databases pretty heavily, and we have built a universal configuration mechanism that can, that effectively serves out the configurations that can, that versions different resources and so on. And finally, for all of our UI needs, GUI needs, we depend on React.js, Redux, and TypeScript. Next slide, please.
So our pipeline is pretty much representation of, I think, everybody that has this kind of model, is that you have unit tests and integration tests. You have a variety of different things. I think the real call out for us is that we are microservices, or we are distributed. So you multiply this by 100 or by 1,000, and then you have olive branches off of different complexity. Like different teams have different needs for different things, and so it can get very messy as you try to compare to each ones. But the fundamental building blocks are there. You have your peer reviews that go into the builds, that go into end-to-end unit tests, that go into a staging environment. You have some of them are go, no-go calls manually, some of them are automated testing, and then you end up just getting pushed into production. And then you have your standard monitoring tools, you have a log analysis, just custom metrics that you've piped through, et cetera. Next slide. Our top challenges within engineering, I think, are pretty relatable as well. Every engineer that you talk to generally will have some sort of element of the engineering triangle, and oftentimes you hear the phrase cheap, fast, or good, pick two. Or in negotiations, sometimes you'll hear you pick cost and speed, or pick two of these variables, and I'll tell you the third one. Right? If you tell me I need something tomorrow and it's got to have world-class search engine capabilities, and I need it tomorrow, great, it's going to cost you $1 trillion because I got to go buy Google, right? So it's always that negotiating, that trade-off. Also, when you're building things, if you focus too much on speed, your quality begins to suffer. You begin with cloud, you end up building all these extra assets, your cost inflates. It's very difficult to build a business off of that. So you have to consciously be conscientious of each of these factors, and it's really easy to get sidetracked. And so how do you introduce quality without sacrificing speed is really kind of what we're getting into. Communication, I think, is one of our #1 constraints for getting work done. So much so that we have engineered our entire solution around breaking into microservices, creating distributed systems. Our agile frameworks have us breaking into small autonomous teams that try to build things on their own, but then how do you pull all those factors in from all these other teams? As you grow bigger as an organization, it's harder, so you try to assemble into what they call 2 pizza teams. I'm sure you guys have been familiar with that, where your team is the size that you can feed with 2 pizzas, as an example with communication. That's why the pizza graphic is there. And then learning as an organization, especially as you get larger, you have learnings and both from successes and failures that happen in silos. How do you take those learnings and pull them across the org so that you're not repeating the same mistakes, or you can take advantage of the successes that one team had and really build on that momentum? And those are really our top 3 engineering challenges. Next slide.
Awesome. So great background. I think we set the stage, right, for this need of continuous reliability. So Gavin, what does that mean to you? What does continuous reliability mean to Expedia? I know it's new because it's what OverOps provides, but I'd love to get your thoughts, and then we can look at sort of how you've solved a lot of these issues with OverOps.
Sure. So with continuous reliability for me, I think it's really easy for everyone to say, if I need to stabilize my systems, it's really easy. I just stop making changes. I stop innovating. I stop making any kind of movement forward, and my systems will be stable as can be. So for me, for continuous reliability is getting before then, where you're talking about where is my key bottlenecks, where my key constraints are, so that we can keep developer productivity. How do you standardize the practices around putting it in where if I pull a developer straight out of college, the wide-eyed, he's excited, he's ready to come in and contribute, how does he take advantage quickly of the organizational learnings that we already have, put them into practice, and be able to make quality software?
I like it.
So I'm going to get into the decisions tree, a little bit of why the top 3 reasons that we picked OverOps. One is the prevention is always better than the cure. This slide talks a lot about the speed of MTTR, which is exciting. If I tell you that there's a faster way to do a triple bypass and we reduce it by 90%, you'll get really excited, right? Like, we can get the surgery done so much faster, we can save so many lives, it'll be so much better. But not having the heart attack in the first place is the better option for the patient, right? So prevention for us was huge, and it gives us that option to do that. The OverOps runs at code level as code is exercised. It picks up the code, decompiles it, and so you're actually picking up issues before it reaches production, which was really key for us. And then also alongside that, you get all the context that is needed to reproduce. I think if you talk to any developer about diagnosing a bug, reproduction is the #1, right? If I can get to the point where I can reproduce the behavior, I can start fixing it very rapidly, right? Like, I can diagnose my code and I can move forward. The minimal effort for a developer to onboard, getting back to that engineering triangle, speed versus quality. If I'm introducing quality, I cannot disrupt the speed that developers are able to create new features, right? So it's got to be that trade-off. It doesn't matter if developers are logging things, right? That's the one thing that's really nice about OverOps is if you swallow the exception or you try to mask it, you try to hide from it, it's not going to go well. It's going to still pick it up. OverOps is still going to pick it up. There's no hiding from this. And simultaneously, it integrates automatically with what you do log. So if you are logging well and you're using some different log aggregate tools, there's a little tiny URL that goes into the log. So if your first place is to find it in the log, put that tiny URL, it then takes you back into OverOps. It's also headless. You can pour a lot of the statistics that are in OverOps to third-party applications so that you can still get that same data. Teams may not even necessarily know that they're using OverOps, but they're there, And so the effort for developers was very minimal. And then lastly, all you can eat license. It's very embarrassing with some of the cost models that some companies have, in which you have a drawdown, right? So you have to kind of guesstimate your dollar amount that you're going to spend for the year. And then if you go out and then you introduce a tool that you've advocated for, and it's got all the bells and whistles, it's really exciting, and maybe you have success and everybody adopts it, they start doing all this craziness. Next thing you know, you run out of money. And you have to go back to your leadership team and explain to them, hey, we're out of money. It was super successful. And then you have to have either the awkward trade-off conversation that, do we get more money to upgrade the scale of the product, or do we scale down and take all the bells and whistles away that everybody was really excited about and start using the product to begin with? And so for us, that was a huge win for that. Next slide. And so OverOps, as far as integrating into our pipeline, you got to think about, what does OverOps really need? And that's where I said before, is it has to have the code executed. And so really for us, it's after your unit tests are run, and then after your end-to-end tests are run, so that you're getting that after the developers have been in the environment and cranking away, doing any kind of manual testing that they might have done, getting those introduction of those use cases. And then of course we are in production as well, so that when those cases that you've tried to predict happen, that you weren't able to predict, you're able to get the context of those as well. And then we have go, no go decisions, whether they're automated or manual, in between some of these gates. Next slide. And so getting started with OverOps, kind of the path that we chose was really installing the service that runs in the container and microservices in either a golden image or as part of a pipeline step that would then bake it into the image. We allowed our developers to toggle the installation, so it's part of their. If you're building a new service, you want to have the confidence. Developers usually want to test their code with, especially any kind of external dependency that's coming in here, make sure that it's not going to do anything crazy. Which, as far as CPU testing, OverOps is very protective of not using too much CPU, so the testing there was very good. I think it's less than 3% was the CPU that we saw as far as that. We put a 2-week soak period after the install before we really put any kind of heavy testing or any kind of process around that. So you get awareness of the issues that are existing in your application, but you're not focusing on the ones that we already know about. So if you've already had your service out in production for a while and you feel pretty good about what you have, maybe you don't need to focus on the issues that are there so much. So we're focusing mostly on new exceptions that are high priority that are coming in. And of course, the OverOps data is collected in each environment as the code is executed. And then we have, as I mentioned before, the go, no-go decision tree defined on the critical exception. So you're having intelligent decisions off of, are we willing to accept the risk of these defects, right? Sometimes you have to make those conscious decisions of, there's that saying that says, show me a code with no bugs, and I'll show you a code that should have shipped 2 weeks ago. You can still make those decisions without having to make, if you have later can circle around on quality, you have a place to target. And then of course, OverOps was great with bringing in support on site, which may not be possible with COVID at the moment, but at least with remotely being able to work with you directly, give you the best practices, what's worked with other things. We have a trust no one model because it is decompiling your code at runtime. And so security was very much a concern for us. It's like, we don't necessarily want to expose our source code, proprietary information to OverOps. So all that's encrypted at rest. OverOps does not have access to it, which was a great model, but they had an engineer come in here and help us get all that situated. Next slide. So a couple of key wins for us, just examples that hopefully are relatable. we had one team that was working on a production issue. As you know, at the large organization, I mentioned communication is a challenge. Sometimes not everyone gets the message that you have OverOps, and it was still fairly early as we were rolling it out. They were hit with a null pointer exception in production, and so they were troubleshooting, diagnosing it, and it took 4 hours for them to ultimately figure out how to reproduce it and resolve the issue. The team did their retrospective and realized that they found out about OverOps and realized that if they had used OverOps, it would have been much faster to get to root cause. And so as an after action of that, they began to use this prior to going to the next environments and basically went on a tear of just eliminating null pointers before they made it to production. And that's difficult to quantify with numbers, right? Because you're preventing the heart attack before it ever happens. So it's untold value there. Next slide. This one's not quite as exciting because you have a P1 issue. It seems like it's pretty much standard. You have a team in production. They're going into their log aggregate tool. They find the tiny URL. They bring it up, and then they get straight to the code with the variables that are inputted from the application, and they were able to reproduce it within 15 minutes. And so then they're able to start working on a hot fix then instead of necessarily rolling back, right? So you have that option then. A lot of times those decisions are very time sensitive. If you have your degradation lasting for a long period of time, a lot of times you don't have that option to roll forward. You have to just regress back and go back to the drawing board. Next slide. And so then as far as OverOps business value, some of the top 3 things for me, quantifiable measurement of quality. And so leadership is always looking for that marker that says, are we getting better or are we getting worse? Do I need to reinvest more into quality, or are we still good to just keep going towards speed or reduce cost? And ultimately that better quality, because you can measure it, you are what you measure, leads to a better experience by the customer. I kind of alluded to it in the last couple examples, but the prevention of impact, I think we can all relate to how expensive a production outage is, not just in terms of the customer impact, the brand reputation lost, but also the engineering impact, right? You pull multiple engineers on a bridge, you have a conversation around it. And not only that, but you're pulling developers from feature work that they would have otherwise be doing things, and you've disrupted that whole workflow. And so that opportunity cost of you spending issues chasing things around that could have been spent on other things is immensely valuable. And then, again, as I was talking before, it's easy enough to implement solutions within OverOps that you are not sacrificing speed to improve your quality, which it's a huge for us. Next slide.
So first, let's kind of summarize what I heard, and it's super important, right? I love the prevention is better than the cure. Finding things sooner, and there's a ton of shift left initiatives going on, and being able to know. I think you said it in the beginning, the gut decision to promote code, put my finger in the air, those things. The problem is when we don't know, and the unknowns are what kills us. So knowingly promoting something that might have issues, at least and that's critical. And having the metrics, as you mentioned, to make data-driven decisions is important. And then when I think of shift right, being able to get ahead of or limit the blast radius, right? So since OverOps, and I'll show you this, when we capture errors, we actually can index the code and we can tell you it's new. And when you know it's something new, and it's in a specific part of your application, like I can't book a trip or I can't book a hotel, and we can tell you that, you can limit the blast radius by getting ahead of it and applying a hot fix sooner. And those are all critical components, right? I think you guys have said it best, like great examples on that. Let me just show you quickly in OverOps, because we had screenshots. So let me just go right to the OverOps workflow. So what Gavin was mentioning is, OverOps, when it detects an error, we're dynamic runtime analysis. We're monitoring your application, I like to call it code monitoring code. monitoring your application in real time. So as errors happen, we get registered for exception callback. We know about them. We can tell you, and we integrate, as Gavin mentioned, being headless. You don't have to go looking for them. We want to tell you about them. And so if I'm using a log aggregator, doesn't matter which one, Splunk, Elk, Sumo, whatever, application logs, OverOps will inject what we call a tiny link, and you heard Gavin mention that. So this, you can see it highlighted here. These links are related to that error. So when you're searching through your log aggregator, and you might search for a customer name or a time window or a transaction, you're trying to narrow down what's going on. When I click on this, I get the OverOps root cause screen, which I clicked the wrong one. Sorry about that. And then the idea is to be able to debug your issue faster. So as Gavin mentioned, we decompile source code and overlay the value of the data at the time of the event. And this is method over method for the entire stack trace. So Gavin mentioned a null pointer, right? And so in this instance, this null pointer comes in. This is an example app, so it's nothing fancy, but you can see the value is null. My problem is how did it get null? And so in this instance, I can see the data list. So this is a list of data. And look, I can see nulls in here. So there's a random generator that grabbed a null value. You could get the picture of it as a developer. Hey, I can see how it got null. That's the biggest challenge. I writing software for a living for years. I always love it when someone says that can't be null. You say it can't be, but it is. Like, you know, it is. So how do we solve it, right? Where's it coming from? Did I not capture it in the UI? Did I change it to null? Did it go down a bad path? You can see the full stack trace, all the data that you need to solve the issue. And this is where, as Gavin mentioned, you know, MTTR reduction by 90%, because trying to recreate the issue from a stack trace can be painful. That's why so many people write to logs. You write extra data. You try to figure out if you can get enough data. And if you don't have the data, then what do? You go and change the logging and then redeploy to get more data. So OverOps wants to give you as much context as possible. We actually capture some additional stuff like additional logging that if you're in production and your logging level set to error, we'll capture log.trace, log.debug, and display them here. We'll actually give you a snapshot picture of your environment at the time of the event. So all this data collected makes it super valuable and quick for a developer to solve problems. Shifting quickly a bit to a shift left world. So in the CI pipeline, right? So it doesn't matter the tool you're using. If you're using GitLab, Concourse, Bamboo, TeamCity, Jenkins, finding things sooner and knowing, so that data-driven approach of let me know about all my tests and are they successful? Because unfortunately, we test for what we know. And as Gavin mentioned, and I've had this happen to me in a past life where people were faking tests, they also were swallowing exceptions, and nobody knew until it gets to production. So OverOps will find everything and give you a quality report, and you can mark your build as unstable. You can work the report, look at my new errors, critical, resurfaced. You set the rules for you. And again, when I click on these links, I get to root cause. So you see how quickly, especially as developers, you check in code, you go home, it runs, all the tests when you come in the morning, you work the quality report. The last thing I'll mention here is exactly what Gavin was showing is they auto create JIRAs for new exceptions. So we can show you, we can tell you what's new, give you a link to root cause. We can give you the server, the app, the version. We're actually getting ready to release integration to Git. So we'll actually do source attach and Git blame API. So we'll actually be able to tell you, did code change, who changed it, and give you a link to that commit. So you can look at the delta. So that next gen component really helps SREs like Gavin. Like when you start thinking of, I got an error, I want to know what changed. And if I can tell you code changed, who changed it, you have the best resource or team, pizza teams, I love that pizza analogy, by the way, of who to get it to get it fixed as soon as possible. So that sort of gives you the landscape of OverOps. Kind of pick this back up here real quick. Ravi, you want to give a quick hiring spiel here?
Yeah, so we are always looking for great engineers and great SRE engineers, great developers. So would love to hear back from you. For those of you who are looking to be part of a really great team that's doing some world-class stuff, Would love to hear from you.
Perfect. All right, so we'll take some questions. Let's see here. All right, so we've got one here. We're using a microservice architecture. How did OverOps help you with managing the complexity? I don't know which one of you guys want to take that.
I can take that one. So
okay,
microservices, is inherently a distributed architecture. It has lots of services, and within each service, you will have multiple containers based on the auto scaling because we are all completely cloud native. Coupled with that, conversation platform itself does asynchronous processing. So if you really step back and look at it, distributed systems, distributed servers, auto scaling with debugging, it's pretty much a nightmare. If you start hitting some issues, it'll be difficult for you to get to the actual problem. So currently, we typically use Datadog to alert failures beyond a threshold, and then we look to Splunk to understand some of the context around it. What OverOps gives us is for us to manage this complexity. OverOps helps us give the context of the issue along with the issue itself, and a lot of times, we find these issues not in production, but we keep trying to move downward all the way to a test. Given that, we don't necessarily have to, the user doesn't necessarily have to log it, and OverOps can still catch it. That is a phenomenal advantage when you're running large-scale distributed, highly scalable systems.
Yeah, that's a great point. I'm going to just add 2 seconds to that, Ravi. We actually are working with several customers who are converting to microservices, and they had some errors happening in production, and they didn't know why. They couldn't find anything in the logs. And in OverOps, we saw the errors, and we could see that they're actually in the catch frame. Instead of doing log.error, they're doing log.trace by accident. So that's that whole point. If it's not logged and no one knows, it's so hard to trace down, right? So you're getting more context.
Yep, absolutely.
So I got another question here. So you're saying there's no foresight needed for OverOps. So I'll take that one. So that's correct. No code changes are required. OverOps automatically finds all the issues and events for you and deduplicates them and classifies them as new or critical, trying to help you prioritize what's most important. But the key part is you don't have to change an ounce of code or have to even know where the errors are. They're found for you.
Just to touch on that, though, I think the human element is the part there that you got to work on. The processes, the things that have to do with that. Taking the key limitation that you're diminishing here is that OverOps is taking you straight to root cause, right? There's going to be some processes that you're going to have to change as part of that. So I think that's probably where most of your foresight is going to have to be in.
For certain. Got another question here. I think it's for Gavin. How do you quantify ROI? I don't know if that's ROI of OverOps or ROI in general. I'll let you take a stab at that.
Yeah, that's okay, a delicate
ROI
question, right?
Thanks, Matt.
ROI
okay. Of OverOps, yeah.
So the challenge there is how do you quantify that you didn't have a heart attack? And that's the part that I think we really struggle with, and I don't know that we do the best of job, is how do you highlight the issues that you didn't have? We did take some, initially early on, took some teams with a very similar error and pit them kind of against each other to see who would how would they react, how would they respond, and that's where we kind of got those measurements of this is going to reduce our time to troubleshoot drastically. But when you start having those key wins where teams autonomously figure out that they should use this tool because it prevents null pointers, and they were able to stop their null pointers from reaching production by just relentlessly attacking them early in the phases, that to us is a win. If you can capture those errors before the developers moved on to another team, another product, another feature, and you're not having to disrupt that work. Those are the type of things where we look at and say, okay, that's our return on investment. Does that make sense?
And there are some other quantifiable ways, like, you know, we have NPS scores, the Net Promoter Score. So I mean, while it's not directly related, you know, just the fact that our conversation platform has a very high uptime, that, you know, that itself will translate into NPS, because the customers can then interact with our systems.
Perfect. Looks like we have one more question. So you mentioned OverOps works sort of headless for you. What are you integrating OverOps with? Because this, I don't know if it's for you, Gavin.
Sure. We kind of started with the fundamental question of where are people working to start with? What are the habits that we can kind of tap into? The log aggregate tool that we use was a common one, because usually we were finding the developers would first go look at logs. And so that was a common place. A lot of our developers are also leveraging Grafana for a variety of different statistics, or some are using an APM. So we leverage the StatsD exporting. So as long as there's a StatsD endpoint that you can ship it to, you can integrate all that data to. The other one that was really important to us is our deployment pipeline. I'm just trying to highlight those errors in the deployment pipeline. That's a key place for us.
Perfect. Okay, I think that's all the questions for now. It gives us a pretty good time to turn it back over to Gary.
Thanks so much. Thank you to today's speakers. It's been really great hearing from Eric, Gavin, and Ravi, and learning from their years of experience. Additionally, we do have 4 lucky winners for today's Amazon gift card giveaway. The winners are Chris G, Devin A, Michael W, and Crystal T. Somebody from the DevOps team will send you an email to confirm your email address and get the gift card over to you promptly. As I mentioned, this webinar was recorded, and the slides will be available to you on demand at devops.com in a couple of hours. And we'll be sending you a link to the slides and recordings as well. It was a true pleasure spending an hour of your time with us, and we truly appreciate that you did. We look forward to seeing you on the next devops.com webinar. In the meantime, stay safe and be well.